Space is vast. It's filled with wonders, stars being born, galaxies colliding. But it also holds dangers. Asteroids, remnants of the early solar system, hurtle through the void. Most are harmless, too small to notice. Some, however, demand our attention. One such asteroid is 2024 YR4. Discovered recently, 2024 YR4 is notable for its size. It's estimated to be over 100 meters wide. That's bigger than a football field. An object that size, if it were to collide with Earth, could cause serious damage. The thought of such a collision is unsettling, a stark reminder of our planet's vulnerability in the cosmic shooting gallery. Thankfully, scientists constantly track these celestial wanderers. They use powerful telescopes to map their orbits, calculating their trajectories years in advance. This early detection is our first line of defense, giving us time to react if a threat is identified. But as we'll see, time is a luxury we may not always have. The asteroid belt, located between Mars and Jupiter, is home to millions of these space rocks. Scientists use complex mathematical models to predict the paths of these asteroids. They look for any potential intersections with Earth's orbit. History has shown us the devastating effects of asteroid impacts. The Chicxulub impact, which led to the extinction of the dinosaurs, is a stark reminder. Today, scientists are developing technologies to deflect or destroy potentially hazardous asteroids. Missions like NASA's DART aim to test our ability to change an asteroid's course. The Double Asteroid Redirection Test, or DART, is a pioneering effort in planetary defense. By intentionally crashing into an asteroid, DART aims to alter its trajectory. If successful, this could be a viable method to protect Earth from future threats. While the threat of asteroids is real, our growing knowledge and technological advancements offer hope. Space is vast and filled with wonders, but also with challenges we must face. Through global collaboration and continuous research, we can safeguard our planet. After all, Earth is our only home, and protecting it is a responsibility we all share. Stay vigilant, stay curious. Dr. Robin George Andrews, a prominent voice in the field of planetary defense, has issued a stark warning about 2024 YR4. This asteroid, which was discovered only a few years ago, has been the subject of intense study and debate among scientists worldwide. His calculations, based on the latest observational data, suggest the asteroid poses a greater risk than initially thought. The data, gathered from various observatories and space agencies, indicates that the asteroid's trajectory has shifted slightly, increasing the likelihood of a potential impact with Earth. While the exact probability of impact is still being refined, Dr. Andrews stresses the need for immediate action. He emphasizes that the scientific community must work together, pooling resources and knowledge to develop a viable plan to deflect or destroy the asteroid before it is too late. "We're in a race against time," he explains in a recent interview. The window of opportunity to take effective action is narrowing with each passing day, and the consequences of inaction could be catastrophic. Every day that passes without a concrete plan is a day we fall further behind. The urgency of the situation cannot be overstated, as the potential impact of 2024 YR4 could result in widespread devastation, affecting millions of lives and causing untold damage to our planet. His words are not meant to incite panic, but to emphasize the urgency of the situation. Dr. Andrews believes that with the right approach and sufficient international cooperation, we can avert disaster and protect our planet from this looming threat. The threat posed by 2024 YR4 is real, and the window of opportunity to mitigate that threat is closing rapidly. The asteroid's size and speed make it a formidable challenge, but not an insurmountable one if we act swiftly and decisively. Dr. Andrews' warning has sent ripples through the scientific community and beyond. Researchers, engineers, and policymakers are now coming together to explore potential solutions, from kinetic impactors to nuclear deflection strategies. Governments and space agencies around the world are now scrambling to assess the situation and formulate a response. International collaboration is key, as no single nation has the resources or expertise to tackle this challenge alone. The question is, can we act fast enough? The clock is ticking, and the fate of our planet hangs in the balance. The scientific community is working around the clock, but time is a luxury we cannot afford. The fate of countless lives may depend on the answer. As we look to the sky and ponder our place in the universe, we must also recognize our responsibility to protect our home. The challenge is great, but so too is our capacity for innovation and resilience. Together, we can rise to meet this threat and ensure a safer future for generations to come. Facing the threat of asteroids, humanity isn't standing still. In 2022, NASA launched the Double Asteroid Redirection Test, or DART. This mission was humanity's first attempt at deflecting an asteroid in space. The target was Dimorphos, a small moonlet orbiting a larger asteroid called Didymos. DART, a spacecraft the size of a vending machine, slammed into Dimorphos at over 14,000 miles per hour. The impact, while seemingly insignificant on a cosmic scale, succeeded in altering the moonlet's orbit. This historic achievement proved that we could, in principle, nudge a celestial body off course. While DART was a major milestone, it's essential to understand its limitations. Dimorphos was a relatively small object. Deflecting something the size of 2024 YR4 would require significantly more energy and time. Still, DART provides a blueprint, a starting point for developing more robust planetary defense systems. The potential consequences of 2024 YR4 striking Earth are grim. This asteroid, hurtling through space at unimaginable speeds, poses a significant threat to our planet. Scientists have been closely monitoring its trajectory, calculating the odds of an impact and the potential devastation it could cause. Depending on its composition and angle of entry, the impact could release energy equivalent to thousands of atomic bombs. The sheer force of such an explosion would be enough to flatten entire cities, leaving nothing but rubble in its wake. The energy released would be so immense that it would be felt across the globe, causing a ripple effect of destruction. If it were to hit a populated area, the devastation would be unimaginable. Cities that have stood for centuries could be reduced to ashes in a matter of seconds. The loss of life would be staggering, and the survivors would be left to navigate a world turned upside down. Imagine a city like New York, London, or Tokyo, suddenly obliterated in a fiery inferno. These bustling metropolises, home to millions of people, would be transformed into ghost towns. The infrastructure that supports modern life, buildings, roads, bridges, would be annihilated. Buildings would crumble, engulfed in a shockwave traveling at supersonic speeds. The force of the impact would send shockwaves through the ground, toppling structures and causing widespread destruction. The initial blast would be followed by a series of secondary explosions as gas lines and other infrastructure fail. The air would be filled with scorching debris, raining down on a radius of hundreds of miles. This fiery hail would ignite fires across a vast area, compounding the destruction. The sky would darken with smoke and ash, creating an apocalyptic scene. The immediate blast would be only the beginning. The aftermath of such an impact would be felt for years, if not decades. The initial explosion would be followed by a series of cascading disasters, each compounding the effects of the last. The impact would trigger earthquakes, tsunamis, and wildfires of unprecedented scale. The force of the asteroid hitting the Earth would send shockwaves through the planet's crust, causing massive earthquakes. These quakes could trigger tsunamis, sending walls of water crashing into coastal cities. Wildfires would rage out of control, consuming everything in their path. Dust and ash propelled into the atmosphere would block out the sun, plunging the planet into a prolonged period of darkness and global cooling. This impact winter would have devastating effects on the global climate, disrupting weather patterns and leading to a drop in temperatures worldwide. The environmental consequences would be catastrophic, potentially leading to widespread crop failures and mass extinctions. The lack of sunlight would cause crops to fail, leading to food shortages and famine. Wildlife would be affected as well, with many species unable to adapt to the sudden changes in their environment. It's a chilling scenario, one that underscores the importance of our efforts to prevent it from becoming reality. Scientists around the world are working tirelessly to develop methods of detecting and deflecting potentially hazardous asteroids. From tracking their movements to developing technologies that could alter their course, these efforts are crucial in safeguarding our planet.